For centuries, breweries and beverage manufacturers have been offering the consumer their carefully manufactured products. Small bottlers were situated evenly throughout the country and thus ensured that transportation and storage times were kept to a minimum. Consequently, the product lifespan was not as important. Today, modern high-performance manufacturers dominate the world markets in all areas of the beverage industry. The diverse selection of different bottles, containers and beverages places high demands on the filling technology of the machine manufacturers. Krones offers a varied range of filling systems for the optimal handling of all types of product and containers. The basic system is known as the VK and is characterized by the short tube filling valve. This is most often employed in the bottling of carbonated beverages, that is, principally in the soft drinks industry. Here, a filling unit sliced from the ring bowl clearly shows that the valve is simple in design and construction. The individual components are the centering bell for the exact positioning and sealing of the container. The bottom piece, here a transparent model, is equipped with pins which control the snifting of the bottle and the return of the cleaning solution. The roller lever controls the inner valve assembly. This control process occurs at 3 positions. The closed position, both liquid and gas valves are shut. The open position, which allows gas from the ring bowl to flow into the container. The neutral position enables free movement of the valve assembly during filling. The vent tube with a rubber spreader is designed firstly to allow gas to escape during filling, and secondly the spreader deflects the liquid along the inner wall. Finally, the fill height is set according to the length of this tube. The gas needle allows the return of gas to the ring bowl. The liquid valve stem assembly controls the product flow. The outer spring places tension on the stem so that it automatically opens when equal pressure in the bottle and the ring bowl is achieved. The filling process occurs as follows. The bottle is lifted up to the filling valve and sealed. The roller lever forces the gas valve to open. The pressure from the CO2 in the ring bowl of approximately 2 bar produces a flow of highly concentrated CO2 into the bottle via the vent tube until even pressure is achieved. The stem is lifted by the outer spring and the filling stage begins. Deflected by the spreader, the liquid runs down the side wall into the container. The displaced CO2 and air mixture escapes through the vent tube back to the ring bowl. The lever is moved to neutral so that if a bottle breaks, the gas and liquid valve immediately shuts. Loss of the product and of the gas is therefore avoided. Once the level has reached the lower edge of the vent tube, the gas return flow becomes blocked and the filling process automatically stops. A siphon-type gas lock prevents the gas trapped in the bottleneck from rising into the bowl. The valve is closed using the roller lever. Immediately afterward, a cam operates the snift valve. By means of a small orifice, the pressure in the bottleneck is slowly reduced to atmospheric pressure. After snifting, the bottle is lowered and passed on to the sealer. The system VKS has been specially developed to meet the needs of soft drinks bottlers. The bottom piece is equipped with a single control pin for snifting. At the end of the filling process, the pressure in the bottleneck is released through the control pin bushing into the open. Snifting and vacuum channels are therefore not required. A variation for the handling of non-returnable one-way PET bottles is the system VK PET or VKS PET. The containers are picked up at their neck support ring. After lifting of the bottle, the centering unit is locked to the bowl using a bolt. A spring mechanism supplies enough sealing pressure to the bottle mouth. Lifting cylinders are therefore not needed. Beer, as a bestseller, places great demands on filling technology because oxygen spoils this noble drink. Minimum oxygen pickup during filling is required here. The system VK2V with double pre-evacuation. Additional requirements for this are a vacuum channel on the ring bowl leading to the filling valve, which only opens if the centering bell is raised, that is, when a bottle is present. In this way, each filling station is guaranteed a constant vacuum even during gaps in the production stream. A valve controls the vacuum in the bottle. And of course, the vacuum pump, which provides enough suction power. After infeed of the bottle, a cam opens the vacuum valve and the air is extracted from the bottle. This is the first pre-evacuation. It results in a 90% vacuum with 10% air remaining in the bottle. Next comes the pre-rinsing phase. The roller lever forces the gas needle to open for a short period of time. The CO2 from the bowl streams into the bottle and mixes with the 10% air to approximately atmospheric pressure. The roller lever is immediately shut in order to avoid the opening of the liquid stem. The second pre-evacuation phase once again produces a 90% vacuum, and in this way reduces the proportion of air from 10% down to 1%. For counter-pressurization, the roller lever fully opens the valve. As happened during the pre-rinsing phase, the CO2 flows into the bottle, but now continues until the pressure is equal in the bowl and in the bottle. The liquid stem opens and the filling phase begins. From here, the course of events is identical to that of the VK. The concentration of CO2 in the ring bowl and the bottle never drops below 99%, and therefore provides the optimum conditions for low oxygen filling. Once the level has reached the lower edge of the vent tube, the gas flow, and thus the filling phase, stops. The tolerance in the fill height is dependent on certain factors and circumstances. Due to variations in the bottle wall roughness, a CO2 release occurs, which is not predeterminable. The foam produced from this finishes the filling process at different levels. Worn or damaged spreaders have the same effect. Deviations in product level and counter-pressure can cause a post-filling stage and therefore overfilling. An abrupt stop can cause filling up to the top of the bottle. Also, different shapes of neck within one bottle type produce different fill heights. Overfill is a bonus for the customer, but profit lost. Krones counteracts these facts with the system VK2VCF. CF stands for correction phase. An additional ring channel with pure CO2 is required. The existing pressure is always about 0.2 bar above the filling pressure in the bowl and is known as differential pressure. This channel is only enabled if a bottle is present. A so-called correction valve controls the correction phase. Up to this point, the sequence is identical to that of the VK2V. Once the filling phase is finished, the lever closes the liquid stem. But the gas needle is still open. The correction cam pushes the control pin, and the CO2 from the channel flows into the bottleneck under a light overpressure of approximately 0.2 bar. The excess liquid is forced gently back into the ring bowl. The entire path from the vent tube to the gas needle is then cleared. The fill height, precisely determined by the length of the vent tube, is accurate to ±1 millimeter. After this, the valve is completely shut by means of the lever. Precise fill heights of ±1 millimeter combined with a minimum loss of product and beer mean that this system completely pays for itself. For can filling, Krones has developed the system VC to handle carbonated beverages, and the system VCC with a pure CO2 pre-rinsing stage to handle products like beer, which are sensitive to oxygen. The filling valve assembly is lowered pneumatically, therefore the can stays at the same height from its infeed until its discharge. Controlled by cam rollers which oppose the pneumatic force, the valve is raised for discharge. As shown in this display model, the vacuum and snifting channels are each released by a control pin. Snifting may also occur directly into the open. The roller lever, operated by the corresponding cams, controls the inner gas valve and liquid stem. An additional channel of pure CO2 is required for the system VCC, which handles oxygen-sensitive beverages like beer. A control valve enables the gas flow. The valve has been forced upward by the cam roller. It is lowered pneumatically. The air pressure shown here in red is variable and determines the sealing pressure, which lies between 1.8 and 2.5 bar. First phase, CO2 rinsing. The vacuum channel is opened and the roller lever is used to release the gas from the ring bowl. CO2 now rinses the can and is drained into the vacuum channel, which serves as a rinsing channel. The gas needle is closed. Next, the cam is pre-pressurized with pure CO2. The pressure in that channel determines the consumption and is always slightly lower than the counter pressure. The result is a concentration of CO2 of up to 98% in the can as well as in the ring bowl, which guarantees a minimum uptake of oxygen by the beer. After opening the gas needle and therefore equalizing the pressure of the can and the ring bowl, the liquid stem automatically lifts as a result of the spring tension, and the filling phase begins. The CO2 flows back into the bowl. Once the level reaches the end of the vent tube, the gas return is blocked and the liquid stream stops. The valve is closed and the snifting pin is pressed. By means of a small orifice, the pressure in the can is slowly reduced to atmospheric pressure. The valve assembly is raised by the cam roller and the can is passed onto the seamer. The straight discharge path allows the product to settle on its way to the seamer.